Elon Musk aims to establish a self-sustaining city of 1 million people on Mars by the year 2050. To transport a population of that size, SpaceX is building the Starship, a vehicle capable of carrying 100 passengers and 100 tons of cargo. But orbital mechanics create a bottleneck. Earth and Mars only align for efficient travel once every 26 months, during specific planetary sync windows. Moving 1 million people requires SpaceX to build 100 Starships annually and launch them an average of 3 times a day during those narrow windows. Reaching Mars has shifted from a problem of bespoke exploration into an industrial challenge of mass manufacturing and launch cadence. Getting off the launch pad is only the first step. A fully loaded Starship burns through almost all of its fuel just escaping Earth's atmosphere, arriving in low Earth orbit without the propellant needed to reach Mars. To solve this, SpaceX will launch multiple tanker ships to rendezvous and dock belly to belly with the main Starship, transferring fuel while in orbit. This requires managing super-chilled cryogenic liquids in microgravity, where fluids float and shift unpredictably. If the transfer is too slow, the fuel can suffer from cryogenic boil-off before the mission even begins. Mastering this orbital transfer is the final choke point. Without it, heavy colonization payloads remain physically trapped by Earth's gravity. Before risking a landing, SpaceX is planning a crewed deep space test mission. Commanded by Chun Wang, the flight uses a Starship V3 to push beyond the Earth-Moon system. The crew spends 2 years looping close to Mars, using the planet's gravity to slingshot back to Earth. This mission acts as a biological and systemic stress test, forcing radiation shielding to function under constant exposure to cosmic radiation. For 2 continuous years, the crew must survive within a habitable volume of 600 cubic meters. At this distance, there is no possibility of an external resupply or emergency return. The flyby is the proof of concept for the entire program, proving Starship can function as a closed-loop survival system before a crew ever attempts to touch the surface. The first mission to actually land will be an uncrewed robotic vanguard targeting the Arcadia region. Arcadia offers specific criteria needed for a base: flat terrain for landing heavy rockets, a temperate latitude, and accessible subsurface ice for water. These ships will carry Tesla Optimus robots. This robotic workforce is tasked with scouting the terrain and prepping the site for the first human arrivals. 2 years later, a small crew of scientists and engineers will land for a 9-month stay. They will be responsible for constructing power generators and testing the first vital surface systems. Human survival on an alien world depends entirely on an AI and robotic workforce laying the physical foundation first. Launching heavy construction materials like steel and bricks from Earth is physically and financially impossible. Instead, SpaceX will deploy specialized rovers to 3D print habitats and blast walls using regolith, the natural Martian soil found at the landing site. In the early years, the outpost remains vulnerable. Survival depends entirely on a flawless, continuous cycle of cargo drops from Earth. True planetary independence requires mining Arcadia's ice for water and rocket fuel, while constructing sprawling, enclosed greenhouses to establish local agriculture. SpaceX is vertically integrating AI, robotics, and orbital logistics into a complete interplanetary supply chain. This 2050 blueprint provides the physical infrastructure for humanity's survival on another world.